Okay, so hello everyone. Let's start with today's POTD, which is 2161. The question's name is partition array according to the given pivot. Okay, so let's try to solve it. The question is marked as medium. Okay, so let's see what the question says. We are given a zero indexed integer array nums and an integer pivot. Okay, so we are given with an integer array which is named as num and an integer pivot. Rearrange num such that the following conditions are satisfied. We need to rearrange the nums, which is an array or a vector we can say, according to some conditions. Now let's see what the conditions are. Every element less than the pivot appears before every element greater than pivot. Okay. Every element equal to pivot appears in between the elements less than greater than pivot. Okay. The relative order of the elements less than pivot and the elements greater than pivot is maintained. Okay. So let me explain you in brief that what these conditions mean. Like here we can see this is our question. It means that we need to arrange the array num such that every element which is less than the pivot in the nums should appear on the left hand side, and every element which is greater should appear on the right hand side, and the elements which are equal should be in the middle. So what does it mean by relative order? Relative order means that here we can see 9 is less than 10, 5 is less than 10, and 3 is less than 10. So they are on the left hand side of the 10, and the relative order is maintained. Relative order it means that 9, 5, 3. So it can't be like 3, 5, and 9. Okay, so this is the relative order that first 9 comes, then 5 comes, then 3 comes. Okay, so let's see how we can solve it. Here are the constraints. Okay, so I have written down the approach. Now let's see what the approach is all about. Okay, so we need to rearrange it in the relative order. So we have taken three arrays: less, equal, and more. Each will be containing the elements which their name is. Like less will be containing elements which are less than 10, equal will be containing the elements which are equal to 10, and more will be containing elements which will be greater than 10, which is our pivot element. Okay, here is our nums array. So now as we start traversing at index 0, the element is 9. So is 9 less than 10? Yes. So it comes in the less array. Now we move forward. At index 1, the element is 12, as we can see. So is it greater than 10? Yes. So it will come in the more array, like it's more than 10. Okay. In the similar fashion, we can see at index 2 comes the 5, which is less than 10. So it comes in the lesser array, or the less array we can say. Similarly, here we can see that it at index 3 the element is 10, which is here we can see that element is 10. So it's equal to 10, so it will come in the equal array. Now at index 4 the element is 14, which will come in the more array because 14 is more than 10. At index 5 we have 3. So is it less than 10? Yes. So it will come in the less array. At index 6 the element is 10, which is equal to 10. So it will come in the equal array. Now what we can do? We can just merge less, equal, and more. So if we merge it, we will have 9, 5, 3, 10, 12, 14, which is our answer. Okay, so how can we optimize a bit? I mean, the solution is very easy. So let's see if we can do some optimization to it. Okay, a bit optimized. Instead of equal, we can take a count variable for it. Okay, so what does it mean? That as here we can see, we are storing the elements which are less than, equal to, or more. So do we have to take this equal? Because equal will contain the elements which is equal to pivot. Equal means, so instead of we can take a counter and count the number of elements which are equal to pivot, and we can just insert it. Okay, so I will show you the code, don't worry about it. I am just telling you the approach now. So okay, so let me first tell you the code, then I will be moving forward. Okay, so this is the first code. Okay, as you can see, we have taken less, equal, and more, and we have done the same. We're iterating the nums, and if it is less than pivot, we are pushing it to less. If it's equal, we are pushing it to equal. If it's more, we are pushing it to more. Then what we have done, we have taken an answer array and we have pushed all the elements of less into it, then equal, and then more, and we have just simply returned it. So as you can see, the complexity is big of n, and the solution is accepted. Now the optimization part. So what I was talking about, that instead of taking the equal array, we have taken a counter which increases as the element, when the nums element is equal to the pivot. As you can see, it increases. So what we have done, we have pushed it into here, and instead of making the new array, we have pushed the counter till counter is equal to 0. We have put the pivot element in it, then we have added more to it. So then we have written the less. In this case also, if we can take the answer, or we can just put the equal and more to the less array. Okay, so now what if we want to optimize these, like these vectors or array we have which we are taken? How do we optimize this? Can we eliminate it? Yes, we can. So let's see how we can do it. Space optimization. Count the number of elements which are greater than pivot and move j backward. So what does it mean? It means that how many elements are greater than 10? Like we have 12 and 14. So what we will do, that we will start putting less elements from this side, from this ith pointer, and start putting greater elements from this side, which is the jth pointer. Okay, so as we can see, the first element comes 9s, I moves forward, and if a greater element comes, j moves forward. So what will happen, that I will come here and j will come here. So the space which is remaining between them, it will be filled with the pivot. Okay, so we can see that I will come here and j will come here after all the operations are performed. So from here to here till less than limit, we have stored it because we have moved the j. See, limit will be here because we have moved the j. J will come out here. So till limit we have inserted the elements, then it will look something like our answer. It will look like this. Here is the limit. Here will be the ith pointer. So in between, what will be? This will be, like in this case, it's infinity. So this will be filled with the pivot element. Now, if we see it's code a bit. Okay, so yeah, here is the code of it. Now let's see. Okay, so what we have done, we have taken I, we have taken j. We had moved j backwards number of times the and the elements is greater than the pivot element. Okay, we have taken an answer array also. So here is the limit which I was talking about, because we are going to move the j, we need to store it. Now here is our answer array. We have what we have done. We have started iterating to it, and if the elements is less, we are putting it to answer I, and when increasing the I, and here we can see we are increasing the j if it's greater than the pivot element. Okay, so at last what we are doing, we are just iterating from I, which is till it's less than limit, and we are putting the pivot element into it, and at last we are returning the answer. So as you can see, the runtime didn't increase much, but yeah, the memory is optimized. Okay, so that's all the three approaches, I would say. See, all have the same runtime, like we have 4. Here we have consumed more memory, so it's like here. Okay, so the approaches are like have the same time complexity, but space is optimized in them. So yeah, that's all for the solution in today's POTD. Okay, so bye everyone, have a nice day ahead.